No, just put them in front of you, please. Okay, so what we're actually looking at is this idea of what happens when I decrease the amount of distance between my 2 points. So at the moment here, this is telling us an x-coordinate of A is 1. So that's the graph of a parabola. And when x equals 1, y also equals 1 in this case. So that x-coordinate, that's there. X equals 1. My second x-coordinate is up here. This is when x equals 2. Y is equal to 4 when x equals 2 on a parabola. So what we're exploring is what happens when I reduce this distance. Currently, I don't know if it'll show up on the video, but in the middle here, this is our rate of change formula. So this is calculating the average rate of change between points A and points B. Currently, that gradient of the blue line is equal to 3. It rises 3 for every one that it goes across. So what do you predict will happen to that 3 if I made B closer to A? Let's say I'm going to make B equal the point 1.8. What do you predict will happen? Just shout it out. It'll get smaller. How come? All right, it's closer together, so it's not going up so far. Can you read out what happened to the gradient? It got smaller. It's 2.8. It's getting a little bit flatter. Let's make this value B a little bit smaller again. Let's say 1.5. What do you predict will happen this time? It'll get smaller again. Did it get smaller? It's 2.5 now. What do you think, if you had to predict what it's going to be down at this point, what would you guess? Started off at 3, then it was 2.8, then it was 2.5. It is getting smaller. What do you predict it's going to be when I get down to that point? Let's say I go 1.4 now. The gradient is now 2.4. Do you think it's going to be 2? Someone said 0 before. Do you think it'll go down to 0? Do you think it'll go down to 2? All right, let's make it 1.3. We're now at 2.3. What's happening to this blue line, this average rate of change, as I get closer to the point A? It's getting smaller, it's getting shorter. What's happening to the gradient of this blue line? It's starting to match the graph. It's almost now, I know it's zoomed in about as much as I can, but I can just tell the difference between the black parabola line and the blue line. You probably can't tell the difference from the back of the room. Okay, let's go a little bit smaller again, 1.2. We're at 2.2. Again, what's happening to that blue line? It is more closely matching the parabola. What do you think the gradient will be right at this point A? Probably 2. But we have this dilemma. If I change that to 1, all of a sudden it doesn't work. There's no line anymore, is there? How come? Because the 2 points are exactly the same. So we're kind of stuck in this space where we can't actually calculate the gradient at that point because there is no line left. The 2 points are exactly the same. The run, if we're doing rise divided by run, would be 1 minus 1, which is 0, and we know we can't divide by 0. So we've got this dilemma. We can't find the instantaneous rate of change. All we can do is, at this stage, is predict what it might be based on making those points smaller and smaller and smaller. If I want to get an instantaneous rate of change, one way I can do it is find the gradient between 2 points that are only a very small distance apart. So if I found the gradient between 1 and 1.0001, we can get a pretty good prediction for what we think the gradient instantaneously is going to be at that point. But it's an estimate, it's not exact yet. It is as exact as we can do at this point in the course. So method number one for finding the instantaneous rate of change. I find the gradient between 2 points that are really close together. All right, method number one, I find the gradient between 2 points that are really close together, and then I use my logical reasoning to say it probably shouldn't be 2.0001, it was probably 2. That makes sense, it's logical. All right, second option, instead of using 2 points, because we know that doesn't work, we can draw what's called a tangent line. This green line is called a tangent line. It is a tangent to the point 1, 1. Would anyone like to have a guess at what a tangent line is? Riley? It's the form of a linear graph. Build on that for me, Nyasha. It only touches the graph at exactly 1 point. So this tangent line touches the graph at that point where x equals 1. It is a linear line, and at this point, it represents how steep the graph is at that 1 point. Once I've drawn a linear line, a tangent line, that represents how steep the graph is at that 1 point, I can then select 2 points on that line and do rise over run for that line. And that's a second way that we can estimate the instantaneous rate of change. Okay, we're going to explore this a little bit further. We're going to play another video to watch. I'm going to stop recording this video.